Okay, so what's up with 1A?
It's definitely maybe the PEMDAS.
PEMDAS. What's that mean?
Please excuse my dear Aunt Sally.
What'd she do?
Parentheses,
exponents, multiplication, division, addition,
and subtraction.
That's right. Please excuse my dumbass son. That's right. Well, now, this next thing I'm going to tell you is one that my class came up with a few semesters ago. It was not me that came up with this. Please excuse my deficient algebra skills. They came up with that. But I like the dumbass son one because some of us can relate to that. So yeah, that's definitely what that is. The problem with PEMDAS is, all right, one thing is anybody on Facebook or even Instagram or something? Every now and again you see these dumb, oh God, it's the bane of my existence. This one guy I've seen on there is like, why doesn't math teachers teach us this? I'm like, shut up. And then you see these things on Facebook about order of operations a lot, about all this disagreement. I'm like, oh my God. So, the thing about PEMDAS is it should be written, it could have been called this. Can you guys see that? I don't know. Yeah. Can you say that? PEMDAS. We all sound a little inebriated, right? It wasn't me, officer, it was PEMDAS. The reason it could be this is because multiplication and division are at the same level. Neither one come before the other one, it's just whoever's first.
Yeah, it's from left to right.
Same thing with addition and subtraction. So it should be written like this. Parentheses, then exponents, then either one of these, and then either one of these. Right? Because, I'm going to blow some of you guys' mind, division does not exist. That was an immediate. Was that a sarcastic? Right? Why do I say that? When you divide something by 4, how does that relate to multiplying by 1/4? Think about it. So if I divide 8 by 4, what do you get?
4 over 2.
You get 2, right? Don't just reduce it. I mean, reduce it, but reduce it all the way. 8 divided by 4 is 2 for sure. And what is 8 times 1/4? Uh-oh.
2.
2, same thing, of course.
Just the way it's written.
So there is no division. There is no division. There's just multiplication by the reciprocal of something. And I'm not trying to freak you out. There is division. Don't freak out. I mean, there's something we identify as division. What I'm trying to tell you is, why does it make sense they're both at the same level? Because they're fundamentally both the same thing. Right? Okay, maybe. So let's take a look at this. So what's the very first thing I do? There's almost no question, even the crazy ass people on Facebook would agree. What's the very first thing I should do?
Parentheses.
Inside the parentheses. I love it. So of course the very first thing you do, you get 4 minus 2, which for most of us is 2. The big mistake I see is I've already done something different than what some of you guys did. Maybe. Did anybody put a 6 here? Everybody being honest? Okay, I love it. If that's true, I appreciate that. And it's okay if it's not true, tell me. It's all right.
I actually got, the answer I got was 9.
Oh, we're nowhere near there. Don't worry. All right. Real quick.
He just meant to do.
Let me see if I can rewrite this again.
Instead of
Oh,
automatically doing
let's
it.
do one more step and then I want to show you something. What's the next step? No question, everybody should get this.
Exponent.
Exponents. 2 squared?
4.
Crazy. Now, let me put this back here. What do I have? 3 plus 4 divided by 2 times 3. Okay. But today's going to be a little bit, how do I describe it? Not frantic, but sort of a little bit less organized because I got a lot of different ideas to talk about with this thing. And yes, I have done this to myself. I didn't have to do the sheet with you, but oh well, that's why it's going to be today. If anybody was thinking about putting a 6 here, that is not fair. That is not fair to this problem. What's the only number that it should be divided by? 2. So, how do I rewrite 4 divided by 2? What's another way to rewrite 4 divided by 2? 4 over 2.
Which is 2.
I know.
Which is just 2, yeah.
And then it says times 3.
You did the division first, so.
But I'm trying to show you why that is true. And then you can say these Facebook idiots and go, I'm not even going to get into that because you all, I can't help you, right? It doesn't make any sense to me why there's anything. That's just the plain truth. 2 is the only number that should be on the bottom because 2 is the only number that's dividing. So how could it be a 6? Somehow that 3 would slide down. No, can't do that. Hopefully. It really makes me sad that there are actually teachers that have taught that multiplication comes before division, period. And if you've ever had a teacher like that, I apologize on behalf of my profession. But I have seen it. I had students tell me that, and then I actually observed the teacher one time, and I saw it happen. And then we had a big discussion afterwards. But anyway, so I know it's happened, right? And that is so terrible because it's the last thing we want. If the teachers can't even get it straight, then it's only going to reinforce in the student's head that, oh, these people barely even know it. Why should I know it? Right? Okay. The worst thing you can do as a teacher who is teaching a kid a mathematical concept for the first time is to, 1, not really understand it yourself, but 2, to not be flexible with the way that the kid approaches it, right? Not everything that they do wrong is going to necessarily be completely useless, right? So often I have somebody do something wrong, and I'm like, that was creative what you tried. Here's why it won't work here, but it could work somewhere else, right? This happens so many times. Okay. So, coming back here, next thing we can do, of course, is division and multiplication. So from the very beginning, you could have identified what's the very last thing I'm going to do. I know it's going to be this guy. Because where's addition? It's at the ass end of PIMDAS, right? I like it. Are you guys okay? I've actually, all right, let me say this. If I offend you ever, if anybody's offended by my sporadic use of curse words, just wait a minute and I'll do it again.
There we go.
I love teaching college because you guys are going to have to be kind of careful. All right, so then we get 2, right? The division is first in line. And then we finally get our 6, right? And like you said over there, I agree with you, 9. Yes. Anybody get the same answer but think they did something different?
I got the same answer.
But did you do basically what I did?
I kind of did it without the fraction. I just.
Oh yeah. That's on the back of the paper, right?
Yeah.
What did I do here? This is my actual work. Right there. On the back of the paper is just some thoughts. Okay. So a few of you guys said that B was rough. What happened with B?
It was just the X and the Y.
Yeah, what's the idea that's being applied here? The first problem was PIMDAS. What's the idea with this problem? Simplifying, but what's the more specific? Combining like terms, right? So right now, before I do anything, I could actually put the Y's together. It's sort of like somebody said, I lost 3 Y's, but I had 10. And it's like, just say you got 7, what the shit? So that's all like terms is saying I can consolidate what I'm saying, all the things that are referencing the same thing. Yes? Now, what is the thing I should really do first? Distribute. Kick ass. So what do you get?
Negative 2x, positive 10y.
Cool. I'm right. That's actually really good for me today so far. If you think I'm writing horrible, that's pretty good for me. So I apologize on this first day for this journey you're about to take through the chicken scratch that is me, right? And now we've got, everything's free. Do you see what I mean? Nobody's stuck. We've distributed because the X and the 5Y were stuck inside. Now they're free to move around. So now what can you put together? Well, we can put together all the X stuff, right? I got 5 X's over there. This guy over here took 2 away. Now, real quick. Did anybody do this? I almost want to write this in pencil, but I don't have a pencil.
I have a pencil if you want.
Let me see. Thank you. Look at Jeff all not prepared. Holy Jeff. I always get somebody to do this. I don't know if you guys can see that. Yeah, you can see that, right? All right. Now don't tell me if you did that. Well, you need the eraser still. Can you understand why somebody's doing that?
Yeah.
What are they thinking?
It's an equation.
It's an equation, because that's what you have to do both sides.
Mm-hmm.
they're already together. There's only one side in this problem, right? Because if you do that, you kind of added 4x to the problem. It's like, you can't do that. It's like getting a check and saying, I don't like them, let me add a 0.
I wish.
Exactly. Try it out, see if it works. 5x minus 2x is 3x, and then how many y's do I end up with at the end?
17.
Yeah, 10, 20 minus 3, 17. Kabam. I like it. I like it. Oh, that's interesting. I'm starting to realize the interesting thing for me in this class is going to be, I'm going to feel, you should analyze my teaching style. You need to, because you're going to be teachers, right? Now, I don't teach elementary school, so there will be a little bit of difference between what I do and what you're going to do. But please, I actually took, real quick, little biography about me. I was going to teach high school, so I took almost all of my certification classes, right? I did the observation, I did everything, and then I decided instead to go get a master's in physics. I did other stuff, right? Just out of nowhere. But so I don't, how do I say this? Anyway, so that's just something that's going to be in my head, I think, every now and again, is I kind of want you to analyze. Oh, that's what I was going to say. Several of my education teachers were the worst teachers I ever had, which is sad. It's very sad. But I realized it wasn't just because I was analyzing them more, it's because they really were bad. But, yeah, so just, I understand. Sorry, go ahead. Were you?
Can you reshow number 1? I got confused on the last part. More like I just couldn't read what was on the end.
Oh. Right, 4 divided by 2 is 2. Did I not make it any better? Oh, so it's chicken scratch, not chicken scratch. Okay, is that any better?
Yeah,
Plus 2 times 3?
It's times 3,
Yes,
not times
thank you.
bracket.
Sorry?
Yes.
Everybody all right? Okay.
So what kind of teachers were they? Were they like bad to students in general or bad at teaching?
They did not stick to their, how this class is gonna work. It was amorphous. They had hard rules at the beginning and then they sort of weren't sticking. Does that make sense?
Yeah.
And that's the worst thing you do as a teacher, especially for elementary students. They want boundaries. And the minute you let a boundary kind of like move over, that's gonna freak them out. They're not gonna know what to do with it. So it's for any age, to be honest, but especially for little ones. But that was one huge thing. And there's a lot of other, I'm not gonna shit on my old teachers, but not more than ever yet. What's up with part C?
Isn't that reducing?
Reducing. Now, real quick, this is not going to work every single time, but this is something I kind of automatically do as a math person. How far apart are 48 and 72?
By 2s?
No. How far apart? What's the difference between 48 and 76? 24. 24. Does 24 go into 48? How do I know it's definitely going to go into 72 also? Because it's counting by 24, of course. So of course it's going to go into 72 also. Does that always work? No.
No.
If these are 24 apart, then any factor of 24 could possibly go into both. I have no idea if you guys are with me at the moment. So it could be 24, it could be 12, it could be 2, it could be 6, it could be 4. Just to give you an idea of what to try. Now, of course, you could do the old thing about it's even, divide by 2, it's still even, divide by 2, it's still even, divide by 2, right? That's fine too.
I took the long way and did long division.
Dude! Oh, I
I
don't.
didn't know. I forgot it was just simplified.
I'm with you. I didn't mean that. I'm sorry.
Yeah, I did.
You should have gotten, well, we're going to see in a minute what did you get?
A half.
Oh, a half, okay.
I took the long way as well, but I ended up getting like 2/3.
Yes, yes. it
That
should be
makes more
2/3.
sense.
Yeah, because of course, if you do it this way, I just kind of said 48 divided by 24 is 2. And I don't even have to worry about this. 72 is 24 more than 48. So it's 1 more 24, so of course it's 3. Right? Does that make sense? 3 24s makes sense because it's 1 more 24 past 48. Okay, so it should be 2/3, which unfortunately, if you did long division, you would get 0.66666.
Well, I got 24 over 48 and then simplified that by 8.
24
And then I
over.
got 3/6, but I made it.
No,
by
stop.
multiplication.
You can't get 24 over 48 because 24 would have to be divided by 2. 72 divided by 2 is
36.
36. Right? If you get 24 up top, you must have divided by 2. So you have to do the same thing for the bottom.
No, I put 48 into 72 or something like that. I don't even know what happened.
Okay. I might want to see that later.
Okay.
I'm curious now.
So much.
Man, I'm having real problems with my threes. My threes are just not good. Let me try him again. Yay, it's all better. Hey, leave me alone. All right. So what about this guy? Common denominator. That's right. You could multiply 12 times 8, but why is that not really the best? It's not really the lowest, right?
It'd be bigger than it needs to be.
Be bigger than it needs to be. And if you ever make your numbers bigger than they're supposed to be, you increase the number of ways to make mistakes, right? So what's a nice quick way to do this? Well, this one's not that bad, right?
No.
What method do you guys use to find LCD?
The big one.
Yes?
Like, not, yeah, so I would multiply 11 over 12 by 2, and then the other one by 3.
But how did you know to do that? That's my question. How do you know it's
12 and
24?
8 go to one number.
Sure. So
That's how I thought of it.
Anybody else do it a different way?
I did the common
Sure.
denominator.
Yes. But how did you figure out it was 24?
I didn't get 24. I got 1 over 32.
32. See, 12 won't go into 32 though, right?
And no, I did I did like the 8 times 12 thing. You know, like you forget
Oh.
the common.
Yeah, okay. Sure. But that would mean that you have to multiply this by 8 and this one by 12,
Yeah.
and then you can combine them. But you should still come out with the same answer at the end. You just have to reduce more at the end.
I kind of just remembered that 24 and 8 can both go into 24. I mean 12 and 8.
Yes, okay, I like it. And of course, you know, if they were a little bit harder numbers, you could take the bigger one, which I thought was where you're gonna go, and just start counting in multiples of it. 12, 24, shit, there it is. Right? Yeah. Right, that's a very common method to use. I want to show you one other method that's a little bit of a sledgehammer for this problem. What that means is it's more than you need, but it actually works beautifully on more disgusting denominators. What number do 12 and 8 have in common?
They can go into 96.
No. What number? 4 goes into both 12 and 8, right? 12 is 4 times 3. 8 is 4 times 2. They have 4s in common. So what does this guy need that this guy has? Let me ask this again. You see, this guy has a 4 and a 3. Pretend like this is a 3. This guy has a 4 and a 2. What does this guy need that this guy has? He needs a 2. What does this guy need that this guy has?
Oh.
A mangled 3. That's right.
That makes sense. Okay.
You see them? And of course it gets to the same place, right? So this problem, that's not really necessary, but when the numbers get a little bit more disgusting at the end, on the bottom, that's a nice way to do it. It's sort of like, anybody have kids? You don't have to tell me, it's a personal question, but you ever give them ice cream and they're like, you got more ice cream?
Yeah.
Okay. So here's they both have, but this one got chocolate sprinkles, and this has got rainbow sprinkles. So this one's like, I want chocolate, so you gotta get, here's your chocolate. I want rainbow sprinkles. Okay, here's your rainbow sprinkles, right?
And they don't want them either.
Does that make any sense? Even if you don't have kids, you were a kid once, you can remember this.
Okay.
It's probably why it's better I don't have kids, because I would just eat both. Like nobody gets ice cream. Yes.
I actually worked a lot of these problems during May and June because I worked with 6th graders. A lot of this math is 6th grade math. I'm like,
Yes.
6th grade math, ew.
Automatic
All
reaction.
right. I won't take that reaction personal. But either way you do this, this guy needs there's ants everywhere. This guy needs a 2. This guy needs a 3. So you get 22 over 24, right?
Mhm.
Minus 21 over 24, which is eventually
1/24.
1 over 24. Yay! Now, of course, if you did the 8 times 12 thing, you'd have to reduce at the end and all that kind of stuff.
I can totally go for some Chick-fil-A ice cream right now.
Dude, why did you? Somehow I managed to talk about ice cream and I didn't want it until you said that. what about E? I think a few of you guys said you didn't like E so much.
I just
Yeah.
didn't feel like simplifying my answer at the end.
Oh, all right.
It was too big.
Listen.
I wasn't sure if I had to find the common denominator again.
All right, this is beautiful. All right, stay with me. This is beautiful. Stay with me. We found a common denominator. I'm not here, right? Because this is subtraction.
Yeah.
I'll stop making that joke because it's going to. So, for example, what is 3x minus y?
Nothing.
Can you do anything with that? No. How about this? Let me see if you guys can do this. What is x squared minus x?
Another X. X.
You can't do it for the exact same reason.
Oh.
Right? This has, how many x squares are here? 1. Are there any more x squares to go with them? No. So to be like terms, same letters, same exponents. Same letters, same amount of each letter, right? Because I can't consolidate. I got an x squared. I got an x. Yeah, I can't put those together. They're not the same thing. Now, what is x squared times x? Oh shit.
2x squared.
You guys can do it.
X to the third.
X to the third, yes. Because what do exponents do? They just accumulate how many things are multiplying. I got 2 x's multiplying times another one. Of course, it's 3 x's multiplying. And now, by now, I think you guys can interpret the number 3.
Question mark.
It's funny. I know how to write the number 3 in like ancient Chinese numerals and Mayan numerals and Babylonian numerals, but I can't quite get it in ours. Do you know what our system is called, by the way?
What?
Our number system. Do you know what it's called? It's Hindu Arabic.
Oh, okay.
We stole it. We said those look good. Give it to us.
Okay.
It's Hindu Arabic numbers. Say that at a school board meeting. Teaching my kids Hindu
Yeah,
Arabic.
sounds more like.
So on this one, this is multiplication. All right, so the big point I was trying to make on the back that I didn't quite get you because I made too many jokes. I got to stop it. To be like terms is required when I'm subtracting and adding. We managed to multiply 2 things, didn't we? We just multiplied 2 things that were not like terms, did we not?
Yeah.
Multiplication is nowhere near as stringent, near as restrictive. Kind of, the whole idea of like terms is building things up. What's the whole idea in this? Cutting things down. I want to reduce. So before you multiply anything, reduce first, right? So, for example, I can't reduce up and down, but does anything go into both of these?
5.
Five.
What about this way?
Just went, what?
7, and of course, remember, 28 minus 21 is 7. 7 goes to both. Yeah, all right. 7 goes into both of those, and you get 3, 4. Is everybody cool with what's happening?
Yeah.
Yes?
That would be 9 and 16.
Good. Is everybody really cool with what happened here? I mean, seriously.
I was
Right.
told that was a no-no.
What's a no-no about it?
The cross multiplying.
No. I'm not cross-multiplying. So I'm glad you're saying this. Now listen. Let me show you what's going on. Watch this. What is 15? Isn't it 3 times 5?
Yep.
Yeah.
Don't I have it times 21? Right?
Uh-huh.
Down here I got 28. And what is 20? Isn't it 4 times 5?
Yeah.
Don't those 5s just cancel?
Yes.
Yeah.
That's all I am doing. There's my favorite sounding. So you guys are going to have to help me if there's ever a time I do something and you're like, I'm not exactly sure why that works.
But it does.
Stop me,
Why not?
right? Because I'm not going to remember every time I do something to go, here's why this worked. But that's the most important. That's one thing I hate about so many things I see nowadays is, here's a trick. No, get past the freaking trick. Explain to me why the trick works. Why does it not always work? Right? Yes?
I have a question about the trick thing. Why does the 9 work when you put your hands down when you're multiplying by 9s? I never knew why. I just learned that.
So it's interesting. So it's related to the fact that any number that 9 can go into, if you add up all the digits, they're a multiple of 9.
Oh.
So like 45. You can divide that by 9, correct? And what is 4 plus 5?
Yeah.
9. Okay. And it's all, and so you can get into, if you wanted to, I could actually kind of write this up. It takes a little bit, but it's related to the fact that 9 is off from 10 by 1. So every time you add 9, you're like adding 10 minus 1. So I can't. It takes a little bit longer to explain than that. Obviously, I could try to write it up. I don't want to take a lot of time right now, but that.
I understand.
Listen, I love that you said that. Real quick, you all know how to tell if something's divisible by 2.
Yes.
If what?
Even.
If it's even. What about 3? You know how to tell if something's divisible by 3. Don't say if it's odd. Don't.
It's multiple by 3.
Yeah, 3 is very similar to 9, which makes sense. If you add up all the digits in any number and there are multiple of 3, the whole thing is divisible by 3. So for example, has anybody ever heard that before? A couple of you guys have. For example, like 1, 1, 3, 4. Oh shit, Jeff.
We can't.
Let's see. 2, 5. Oh yeah, that's fine. You can't see it yet. I'm not done yet. I think that'll work, right?
Yep.
10. Yes. Okay. So if you add up those digits, what do you get?
12.
Which is divisible by 3, so 3 goes in. Okay. All right. What about 4? Anybody know how to tell if 4 goes into something?
8, but 12.
Stop. If the last 2 digits are divisible by 4, the whole thing is.
Oh, yeah.
Because 4 goes into 100. Therefore, 4 goes into 112, or 116, or 232, or, do you guys see what I'm saying? Maybe? So, this number 4 will not go into, will 4 go into this number? Yes, because it goes into 88. Isn't that crazy? Has anybody ever heard that? This is, yes, somebody asked, sweet. So often, I get most of the classes never heard of it, and then I ask them, think about it, are you a little upset that you don't know this? We created the numbers. We're humans. We made this shit up. We're supposed to know. We should know this, right? And now I know we have calculators. Oh, I got a calculator. I don't care. We should kind of know this, right? That would really help when you're doing something really quickly. You're not allowed to have a calculator. It'd be great to know this shit. 5 is easy. You guys know 5.
Yeah.
6 is just a combination of the rule for 3 and 2. It's got to be a number that when you add up the digits, it adds to a multiple of 3, but it also has to be even, so that wouldn't work. Why does that work? Because 6 is 3 times 2. Isn't that cool? No? What about 7? 7, there's nothing for 7. There actually is something for 7. It's a little bit more complicated. I gotta look it back up now, because I only recently found out there was something for 7. So maybe, I'm sorry.
I actually just did that before, so why I have to get it again. But one of the professors that I took actually had us look for all of them.
Okay, good. It's probably Carrie. Because I think Carrie's the one that told me about this the 7 one.
It wasn't here, it was actually a mix up.
Oh, okay. I don't know. And then 8 is actually the last 3 has to be divisible by 8, which is kind of gross. And that's enough of them. Okay, sorry. Man, I will do that often. Go off on tangents like that because there's so many little things that it's impossible for any teacher to tell you all of them. But when I think of them, I'll tell you. Is that guy still going?
Yep.
Okay. Good. You let me know if he takes a break.
Okay.
And then of course the last step here. I'm sorry. I think somebody already told me.
Yeah.
9,
16.
16. Select. Now think about it. If why does this make sense? If I multiply, sorry, good.
I was like, oh wait, never mind, not my bad.
I think you're the one that told me what it was. Okay. 2 numbers that are less than 1. When I multiply them, the answer will be even smaller than either of them, and that only makes sense. If I cut something in fourths and then I cut that in fourths, I'm going to get this little tiny pie slice, or I'm going to get 1/16 of the pie, correct?
Yeah.
So I think you guys probably already know this. When you multiply 2 numbers less than 1, the answer is even less than either one. That's the one time we multiply stuff and they get smaller, the answer. Okay, like it. And then this one, I think, I don't know. I'm curious about this one. How did you guys do this one here? Anybody?
I changed them into improper fractions first.
Improper
And then
fractions?
just subtract between them.
I did the whole like 7 times 4.
Yes.
And then plus 2 and then
I like it. Do you guys know why that works, by the way?
Nope.
It's just easier because it's easier to.
No. Not why do you do it. Why does it work? Alright, so real quick. And see, this is where my job is to make sure that even if you don't care, I tell you anyway. But your job is to care, alright? Your job is to care. I want to know why the hell that works. You shouldn't be like, this guy told me that works, it works, and I'm like, I don't know why it works. Tell me why it works. Yes.
I think I know what. Can I
Oh,
go
good.
back?
Yeah.
So the first one is like 4 and then 2 over 7, right?
Okay.
So if I do the improper fraction, it'll be like 30 over 7, which means that how many times 7 can fit into 30 is what we put on the side. And then
Okay.
what's left-
Now watch. I love that, but you're kind of thinking about from the end to here.
Yeah.
All right. This is one of the most evil notations right here. This is probably the most evil notation because normally when things are sitting next to each other, what does it mean? Multiplication. This does not mean. What does it mean? What actually is hidden right here? Addition. Now tell me. I'm about to show you why the shortcut works. I'm not saying you have to do it this way, right? I always get a students like, why is he making this shit so hard? No, I am showing you why it works, the way that we're going to always do it. So this is actually this, and then this is over 1, and there will always be an over 1 here, won't there? Because that's going to be a whole number. And then it needs this, so you're going to multiply by 7 and add 2. I mean, so of course it's y. And then of course it's over 7. Are you guys kind of with me?
Yes.
Okay, I like it. Maybe. Okay. You guys gonna remember that? No?
Probably not.
Oh yeah, you can't see my facial expressions. I got a big sad face now. Okay. So the shortcut is 4 times 7 is 28 plus 2 is 30. And what did you guys get for this one?
19.
Oops, sorry. Yeah, 7 times 2 is 14 plus 5 is 19.
Except for the over 7 part. I just scratched the 7 out. I should have done that.
Oh, so that would be, so if somebody's like, I owe you 4 and 2 7s dollars, and you're like, well, give me the $30. Do you understand what I'm saying? It's got to still be over 7, or else you've made it become much bigger. It was 4 and something. It can't equal 30, right? So these have to be equivalent to each other. And how do you check? Just like you were saying earlier, 7 and 30 is 4 with a couple left over. Left over 7, right? So when you say left over, it's left over 7. Okay. And then of course you get
11 over 7.
which you can change back to a mixed number.
1 and 4 sevenths.
7 goes to an 11 once with
4 over 7.
11 minus 7 is 4, right? Yes?
For these problem, for that one specifically, would you have to simplify it back to a mixed number? Because that's what it started out.
In general, when I'm teaching courses where we do this, the answer should be in the same form as the
Yes.
problem.
Okay.
Right?
How did you get 4 again?
So 7 goes to an 11 once with how many left over? 4, because you add 4 to 7 to get 11, right? Think about it this way, real quick. I got something for everything, everybody. That's right, I switched to this paper. What was I going to show you? Oh yeah, 11 over 7, right? If only that was a 7 up there, that would be easy, correct? But isn't there a 4 also, right, to make the top 11? Yes? Isn't this 1? Isn't this 4 7s? Right?
Oh.
Yes? Oh, there you go.
Yeah, now.
All right, so this is what I'm saying is missing from a lot of math education now is these connections between shortcuts or even not even, I mean, this is a shortcut. These are shortcuts we're using, but sometimes the first teacher to show somebody, maybe they forgot themselves, which is sad, or they just were like, I'm just going to show them shortcuts. And then the kid never knows why it works, right? And of course, they're not going to speak up when they're like 8 or something, right? Tell me how it works. They're like, that's what teacher said. Okay, sorry. So let's see. Oh, I did that one already. Yeah, okay. 1 and 4 7. No, what did we get? 1 and 4 7s. Oh, I was going to do it a different way. That's right. So there's another way to do this problem. Did anybody do this a different way? Okay, now, let me see. I have stupidly taken away my room. So let me do this. 4 and 2 7s minus 2 and 5 7s. How do you do this, by the way? Let me see. How do you do this? How do you do 21 minus 9? If you had to do this by hand long ways. And then of course that's 12. Let me make one more interesting. 843 minus 18. What would you do?
Borrow.
Borrow. Why does borrowing work?
I don't remember.
Exactly what would you do?
It would the 4 would become a 3, and 3 would become 13.
Because of course, if 40 becomes 30, that's an extra 10 that you put on 3. Exactly, right? Yes? Now, keep that in mind. I can do this the exact same way. Isn't 2 smaller than 5? That's bad. It's sort of like 3 being less than 8. So let me borrow 1. And isn't 1 7 over 7? So now this becomes 9 sevenths. We do that again, a little bit more room here. What was that again, Jeff? All right, here we go. So we've got 4 and 2 sevens. Jeff? Minus
2 and 5
2 and
sevenths.
5 sevenths. I talked to myself a lot. So this will be 3. I'm going to borrow 1. But isn't 1 7 over 7? Yes? Just like the 1 actually meant 10 because the 4 actually meant 40, right? So that makes this become 9 sevenths. Now, part of your brain says, kind of balks at it, like, that's not allowed to exist. Well, neither was the freaking extra 1 over the 3 you were going to do on the last problem. It's not allowed to exist. It doesn't actually exist, does it? It's just work. That's all it is. So that's why there's nothing wrong with that. And then I've got my minus 2 and 5 sevenths, and what do you get?
1 and 4 sevenths.
1 and frickin' 4 sevenths, the same thing we got, right? Yes? Do you guys remember that? The borrowing thing? No?
Yes.
A little bit?
I have to do it.
You guys, are you guys okay with that?
Yeah.
You never have to lie to me. Right? You can be totally upfront, say, I hate that shit. And then hopefully these two, I saw a few people that were doing this one ahead of time. This shouldn't be too evil. This one's a little bit like the most evil phrase in English, trying to translate to Mathish. 5 less than 3.
It's not -2.
Good. It's -2.
No, I got that.
Because 5 less than 3 is 3 minus 5. That's not math's fault, that's English's fault. Right? If anybody knows 2 languages, you know that English is the harder one out of the 2. Bottom.
Is it
Line.
3 minus 5?
Yeah, 'cause
Yes, good. But 3 minus 5.
I'm so glad. And that would be -2. Oh my god,
I know the
I
answer, I
put
just
2
don't know
or
it.
-2, but I'm so glad I got it right. Yeah.
And then this one, 2 more than the product of 9 and 8.
9 times 8.
2 plus 9 times
9 times 8 plus
Nine.
2.
9 times 8 is
8 and 72.
72. And then 2 more than that,
74.
74. So this would be 2 more than. So the product of 9 and 8 is 9 times 8. 2 more than that is this. You could have written it the other way, 2 plus. So 72 plus 2 is 74. Bam! I like it. All right. You guys feel better about that? I like that. I don't like when I first give it out and everybody sort of goes, oh shit. But do you see what kind of discussion we had about this stuff? And this is like bringing up old stuff and identifying stuff you feel there were holes in what you knew and there was stuff you forgot and all this kind of stuff. A lot of stuff. So, let's do this. We're going to get a little bit into the book. All right, so if you don't have the book, I'm going to put it up here, I think. I'm going to see if I can't get an online version. That would be easier. Actually, okay, let me see. I'm trying to figure out if I want to go through the definitions first or if I want to throw a problem in. Yeah, let's throw a problem in. Okay, yeah, I like it. Look here, so I'm on page 8. On page 8.
Yes.
Okay. So go ahead and put on your paper this little triangle of circles. And I need you to put the digits 1 through 6 inside the circles so that the sum of the three numbers on each side is 12. Does everybody get what I'm saying? So these three have to add 12, these three have to add to be 12, and these three have to add to be 12. Let me make sure I'm not showing any part of the answer. Try not to look at the answer if you have the book. Just give it a try. This is a cool little. Does everybody understand the?
No.
All right.
I'm a little confused.
Place the digits 1, 2, 3, 4, 5, 6 in the circles in such a way
Each side.
that the sum of any three in a row is 12. Are you here for 125?
I think so, yeah.
The elementary math?
Yeah.
Yeah, okay. Where did I put go ahead and grab a seat. Here we go. What's your name?
Maryland?
Mia? Ramos?
Yep.
Yeah.
Yeah.
Oh, okay, good. We did this earlier. I'm actually recording the lecture, so I'm going to put the, so you can kind of watch the lecture later to see all the steps we took. And, oh, this is for me, so. And now we're just working on this problem. I'm going to zoom in a little bit more now that I'm back here. I'm not used to such a big freaking room. This is huge. Zoom in. Has anybody figured that out yet? Don't say it. Just sit there and feel good. That's right. All right. You think you have it?
I think so.
Don't say anything. It's going to add the 12. What do you do it this way, and this way? Yeah. Yeah, you pretty much can solve this now.
Yeah.
Uh-oh. Oh, yeah, that's an issue. Now, I don't know if this came into your thought process at all, those of you who got the answer. But I'm sorry if anybody's still working. It's we're going to talk about the problem now.
Finally.
Anybody got the answer? Did you just get it completely trial and error, or did you realize something?
I just did like the three equations that you can get with those three numbers, like 6 plus 5 plus 1, 4 plus 6
Oh,
plus
good.
3
All right, good.
3 plus 5 plus 4.
Fantastic. So you could at the very beginning is just say the given numbers, how can I make 12? That's a really smart first step because only one of those ways is going to work in the circles. And then you just got to figure out where to put them so that they're in the right place. Anything else about? Yes.
I just put the biggest numbers, so 4, 5, and 6 on the corners,
Yes.
and then I just. figured
Yes.
it out.
That's a huge realization. You could have either said the bigger ones out or the smaller ones in,
Yeah.
right?
Yeah.
Because if I want to make them add up to be 12 and they're already small, what numbers do they have to share are the bigger ones, right? That's the only way they have a shot. Does that make sense? You didn't have to think that way at all to get the answers. I'm sure some of us just kind of like, let me try this, let me try this, let me try, oh, that works, yay! What did I think? I just thought, make it work. That's what it is.
Yeah.
Yeah.
I did the trial and error, and then I realized that 6 had to be. Then I realized the bigger numbers had to be on the outside.
Okay, good. So, real quick. The funny thing, I love the very first thing. I sort of led you this way, but the very first step in solving problems is to understand the problem, all right? So I sort of said, does everybody understand? But I love that it's sort of like somebody said, I don't have a clue. And you just said, what the hell are you talking about? Right? So, but you have to kind of stop yourself and don't make assumptions. So very often a student will read through real quick and just go, let me just add these numbers together, whatever. You just got to make sure you know what the problem is asking for, right? Did they give you information that's unnecessary? Have you ever seen a problem like that in math? Yes. You know, like, they told me there were 7 goldfish, and it didn't matter. It's like, who cares about the goldfish? All right, I like it. So you can kind of follow through what they give a different kind of way to think about things, right? But I like, normally people kind of start to realize, like I said, the bigger numbers have to be out, smaller numbers in. Let me do another one with you guys. I don't want to get too far ahead. I think this comes up pretty soon. Oh, that one's neat. Well, all right, let me do this. Okay. I like this problem. And then we might even, if I can get that video quickly. I need to keep an eye on the time, too. I know you guys will probably help me with that. So real quick. Today's a little bit weird. We are getting into the book a little bit. The way this, has anybody noticed the class, how it's done? We start with the class and then we're supposed to have a lab.
Yeah.
And of course that lab is going to involve stuff behind that door there, right? Boom, boom, boom. There's chemicals. No, there's like I said, there's manipulatives and there's other stuff. So every now and again I'll bring stuff out. And it's just stuff that your kids are going to use to kind of get to know fractions and all stuff. So of course we got to freaking know how to use them before we're going to have them use them.
Like blocks?
Yeah.
Like what else? Sorry?
Like
Blocks, yes.
The counting blocks.
There's blocks that represent different fractional amounts. Yeah. Okay. All kinds of stuff. Yeah. Math with toys.
I love toys.
Yeah. What was I going to show you? Oh, yeah. Okay. If you played Tetris before, you know about this. So there's a shape in Tetris that you always really want to have happen. Anybody ever played Tetris?
Yes.
I've done a horrible job. But this is supposed to be 4 equally sized squares. So just pretend like that's what it is. So I always forget how to pronounce the tetromino. Is that what it says? Tetromino? You guys, I don't know, Jeff. I'm pretty sure it's a. Let me make sure I know. Yeah, tetromino. Okay. I always forget that name and that's where the word Tetris comes from. That's where the name of the game comes from. It's a tetromino. Tetromino is any collection of 4 squares, but they have to share an entire edge. They can't just share like this would not be a valid picture to make. That's not a valid tetromino, right? Because it only shares a corner. It's got to share an entire edge. Can you come up with other tetrominos besides this one? Okay, draw them. And of course, anybody who's played Tetris, you have a little bit of an advantage. So again, it can be any shape where you have at least, where every single square has to share an edge with another square. Let me see if I can access this. Oh, do you have an idea? No. There it is. Oh my God. I remember my password. Maybe I can get some audience participation.
Do we get extra credit?
Yeah. Anybody want to draw some up here? Come on up. There's 4 of them. So.
You just pop it.
It's going to suck if somebody takes yours. It's interesting. We'll see. If you figured out how many there are, well, let's see.
It can be any shape, right? That's what you
It's got to follow the rules. So we're going to be the judges out here if they follow the rules.
make a square. If that makes sense. I never played this.
Oh, really?
I feel like I'm cheating now.
Only draw one. Oh, yeah, only draw one each. I don't want you to take too many of other people. You're good. That's a good option there.
Wait, I didn't do this correctly.
What do you mean?
On my paper,
Oh.
I drew in triangles because
Neat.
I was like,
Oh, you thought I was making other shapes besides squares.
Yeah.
They have to be 4 squares. And they have to share, see, they have to share an
Yeah,
edge.
yeah. So
Every
I-
square must share an edge with another square. So you've
That
done
makes
beautifully.
sense.
And you wanted, let me see.
Just one.
Yeah. I got you. You got all, these 2 are really the same, right?
Yeah, I just did.
Yeah, I'm with you. I'm with you. Only 4 though.
Oh, that makes more sense.
Yeah. So I already got that one.
I just thought 4 squares, so maybe I just.
That'll work, but it's pretty much up there already. But that's all right.
Oh. Yeah, I didn't see what you
All right. Does anyone have one that's different
Not
from up here? Come on up.
I got one.
Say again.
I got that one, the blue one.
Oh, okay.
And,
That's what I got too.
huh.
Yeah. I got a good one and I got a bad one. This one got to be thrown out. Sweet. All right. And then anything else? Come on up. Let's see who gets here first. There we go. Yeah, oh yeah. Thank you. Let me see. Oh yeah. I got to see if I can get this. Oh. Please tell me it's in this place. Here it is. Let's see, did you get the one I was thinking about? Sorry, everybody. I might just, let's see. If I can't get this real quick, I'm gonna give up on it. That worked. That's probably not gonna come up in time. Let's see, did that one come up here? Yes, yay! This little dude, right? And of course, there's actually another variant of that one. Yeah, but yeah. So something that's just a pure rotation is considered the same shape, but something that's a reflection wouldn't be, right? And of course, when I say variant, I have a certain TV show in mind when I say that. I don't know if that happened to you guys. All right. I don't think any of these want to wipe out all of existence, though. Yeah, I think, yeah, let's do this. It's going to take me too long to find the one I want to show. I'll find the one I want to show you guys. So one of the first videos I want to show you involves one student doing exactly what we just did. And it's really interesting watching videos of young students working through a problem because you get to see their thought process. And the person with them kind of tries to draw that out. What are you thinking right now? Why did you do that, right? And it's really important, even if something they're doing is not going to lead to the right answer, you still want to understand what they're thinking, because they could be thinking the right thing and doing something not quite right. I'm not sure how to say that, but it takes a little bit of practice. Have any of you guys ever tutored before? Anybody? Yes? A little bit?
Yeah.
It's a really good idea, is to try to tutor. I'm not talking about advanced quantum mechanics. I'm just talking about young people, about the age you're going to be teaching. Tutor somebody in all these different subjects. When I became a math tutor and you have to jump from calculus to pre-algebra to differential equations to whatever, your brain has just got to kind of go between those ideas very quickly, and it really, really hones your abilities. So it's a really good idea to tutor almost anything, to be honest, especially elementary school. You got to know a little bit of everything. But I think that's enough for today. What do you guys think? We'll leave a little bit early. Why not, for the first day? Is anybody upset about that?
No.